And go. So lesson 4 gets its own little kind of separate part because we're doing division. Now, when you have division, that's like, they're called rational expressions. Why are they called rational expressions? Anytime a denominator or an x is in the denominator. Okay? So if x is in the denominator, something weird goes on. Okay? Like when you have, if you're just graphing y equals 2x plus 3, well, x can be anything, right? We just say, yeah, x in the reals. But if you had y equals 1 over 2x plus 3, well, that's not as straightforward anymore because x isn't allowed to be everything. X can be everything but what? No. X can be 0 here because 2 times 0 is 0 plus 3. 1/3, you get an answer, right? Negative. What would it be? Okay, so maybe you got to go through this. We know that 2x plus 3 cannot equal 0. Okay? Do we all agree with that? Now maybe it's kind of hard, like it just doesn't, I don't know, it's something, like it's 1/3, 2/3, I don't know, negative, it's negative. Well, you can actually just do the algebra on it. So to solve this, I would first do minus 3. 2x cannot equal negative 3, right? And then I can divide by 2. X cannot equal negative 3 over 2. Okay? So that's what's going to change. And division, you know, when we're talking, when we have two fractions, now addition, subtraction, the common denominator, you know, that common denominator that always haunts us. Now, here's one thing that you got to be really, really careful. So I'm going to come way on the left. It's when you have y equals x plus 2 over x plus 3. And this happened a lot in the last class. The students would come up to me and they would say, Mr. Tribbett, it only says x cannot equal negative 3. Why does it say negative 2 as well? Yeah, the numerator can equal 0. But that's what starts to mess with you a little bit. After you do a few of these, people are coming up and they're getting what they used to know, they are now confused with. Okay? Because when I just said, you know, if I just said y equals x plus 2, what can x be? Everyone would say x can be anything. Good. Now if I go 2x or x plus 2 over x plus 3, I have some people saying that x can equal negative 2 now. Okay? So we want to be careful now to not mix up numerator and denominator, and also to make sure we get all the numerator and denominators correct when it comes to non-permissibles. Yep. Because if I had y, say, was 0 divided by 3, that means if I have 0 pizzas and we divide it into 3 people, I can guarantee you each person is getting nothing. I can guarantee you. But what if I brought 3 pizzas into the room and I said, now, and it's an empty room, and I go, okay, everybody, eat. Okay, I'd come back and nothing would be taken. Because you can't divide by nothing. But you can take nothing and divide it by a bunch of people. They're not going to be happy people, but you can do it. Okay? It's kind of like one of those math jokes that aren't funny. You know, hey, you guys, we have pizza. Okay, go. There isn't any. Yeah, I know. I was showing that if you have 0 pizzas, nobody can have anything. Okay? So you can see how those aren't the most exciting parties in the world, those math fun parties. So always remember, you can take nothing and divide by 3 people. There was actually, a long, long time ago, there was this, there were shares of this one gold mine, and the shares We're going up and up and up and up for this one gold mine. And the next thing you know, the CEO of a company jumps out of a helicopter, because what was about to be released is there was not one bit of gold. It was all fabricated. And I even had a friend that had shares in this stuff. Like, I mean, it was huge in Canada. So here's a bunch of people that have divided that gold mine. Now, how much did each person get? Nothing. Okay, they lost all their shares, right? And the CEO, he did commit suicide because he knew it. He was part of the whole thing, and before it got out, right? So, you know, you can take nothing and divide it by a lot of people. Now, when we graph this, though, like we did this graph today, and we had this picture, you know, times this picture, and we got this picture. Well, when we divide two of them, well, sometimes we're going to have that non-permissible. What is it going to look like? So here, we're going to just figure that out. So if I had at x equals 4, okay? So at x equals 4, here's 4 right here. I am looking at my 2 y's. So there is 14 divided by 2. So 14 divided by 2 gives the answer of 7. So now, in line on the 4, I'm going to put 7 in there. Okay? There's 7. Okay, now let's keep moving. We'll move left. So how about at x equals 3? At x equals 3, so I'm here right now, at x equals 3, that would be 6 divided by 1. 6 divided by 1 is 6. Okay, so that is like an invariant point. It didn't move. Then the next one, at x equals 2, I will have 0 divided by 0. Now, obviously, there's a great argument for saying, well, that would be 1, because anything divided by itself is 1. But no, the rule is when you divide by 0, it is always undefined. So let's go plot undefined. Now, it isn't the asymptote that we've used in the past. Okay? So you can't really plot this point. So how do you keep going? Well, you kind of skip that point and you go to x equals 1. Well, when x equals 1, that is negative 4, because that's down here, right? Negative 4 divided by negative 1, and you get the answer 4. So it's negative 1, 4. Okay? So let's just do one more. Let's do 0. At 0, and make sure not to get your graphs mixed up, eh? Because it's easy to do g of x divided by f of x. Well, we got to still put f first. So that is negative 6 divided by negative 2. And I get the answer 3. Okay? So that would be right there. Now, the whole, I guess, new thing is like, okay, well, like that undefined, and what am I supposed to do with it? So undefined actually gets one of these. And the reason I know it is there is because I'm seeing a pattern there. So when I was dealing with x equals 2, I'm going to put it within the pattern. Okay? And the graph then looks like this. So how do we deal with that undefined? It is a hole in the graph. Okay, so again, we always got to get the visual and the equations, like how do they relate, right? Because the diploma loves to see, do you know what the picture of this looks like? Are you good at problem solving if I just gave you a picture like I did for question 3 on your quiz today? I just gave you the picture. Could you do the math from it? So we did that. But now they kind of let it out that this was the two equations. X squared plus x minus 6, that's the parabola, and x minus 2 was the straight line. So it says, well, what would be the equation of that new line? Okay, well, we'll do that, right? So y would equal x squared plus x minus 6 over x minus 2. Now, what we want to do is we want to be able to actually see, like, how does this turn into a straight line? Well, we can factor the top. And what I learned from the other class is that it's been a while since we factored, so it caused some growing pains there. So when you do these, remember there's a 1, and it's what two things add to give me 1, what two things multiply to give me negative 6, and those two numbers would be 3, negative 2, 3, negative 2. So this would turn into x plus 3, x minus 2, x over x minus 2. And what happens conveniently is the x minus 2's cancel, and you are left with x plus 3. And you can put x plus 3 into your calculator. It's going to give you the nice graph. But I need you to be very, very careful, especially in your diploma, that x squared plus x minus 6 over x minus 2, does it equal x plus 3? Aren't these two going to give a different graph? Would the left side give the same graph as the right side? I can guarantee you it shouldn't. Like we've always learned, but left side, right side, like if I get that, why is left side different than the right side? The way it stands right now. Well, actually, it's y equals x plus 3. So, but on the right, if say I just gave you this equation, okay? So forget everything that we just did, and I just said y equals x plus 3. Does y equals x plus 3 have any restrictions? No. Does x squared plus x minus 6 over x minus 2 have any restrictions? Yes. So these two right now are not equal. To make them equal, you will have to write this. X cannot equal 2. Now they are equal. Now, if you just came up to me and you said, you know, Mr. Shaw, I was like looking through the textbook, and they're like, graph this. Y equals x plus 3. X cannot equal 2. He wants me to graph that. What, x can equal 2? 2 plus 3 is 5. Why is it doing that? And I'm going, because it came from somewhere. I bet you anything that it was over x minus 2. So it's stating that restriction. So the moral of the story is, any time in the question, if it's bad, it is always bad. Okay? Like, say you got a hockey tournament next weekend and you get suspended. And your tournament's on Friday and Saturday. Okay? On Friday, you're like, okay, you stay home. And then Saturday, you show up and you say, I'm ready to play. So, no. You were suspended for the whole tournament, not just Friday. Okay? You can't come the next day either. So, if you were suspended, for that entire question, it is never allowed, even if it cancels out. Because that's where they're going to try to catch you in the diploma. They're going to go, I wonder if they know even if you cancel it out, it's still bad. It's still not allowed. Do they know that concept? Okay? And again, that's a little nugget you need on your study sheet, because in 4 months, you're probably going to forget that. You read over your study sheet and you're like, oh yeah, I remember that. Okay? Because at the end of the year, you won't even know what you don't know. And that's actually kind of scary when you're like, I have no idea like what I suck at right now. I have no idea what I'm doing. So then you start doing diploma questions, and then you're like, oh, I don't know how to do this. So then you feel a little bit better because you're actually finding out what you don't know. But still, that's missing some gaps too, because I can't ask you every question in the world before the diploma. So there's several little things that we're going to have to be highly aware of when we are doing these with rational expressions. Okay? So here's something you just need to underline. We refer to that hole in the graph called the point of discontinuity. Point of discontinuity is a point that is not allowed because somewhere in the question it was a non-permissible. And again, that is any time. There's no exceptions. Okay, so let's kind of be diligent in which questions we do, because we just don't want to waste time. Okay, now here's a good question. It says take f of x, so it wants f g of x, okay? Okay, so I'm going to take x minus 2, and I'm going to divide by x squared minus 5x plus 6. Okay, now at this point, there's nothing really to do. But I can factor the bottom, and it factors nicely to x minus 2, x minus 3. Okay, two things that add to get negative 5, multiply, give me 6. And what cancels nicely is the x minus 2's. So you get 1 over x minus 3. Okay, now if I was writing a multiple choice test, which I do from time to time, I would have this as the answer, and I would get the biggest number of people grabbing that one. And some people are looking at me like, yeah, why wouldn't you pick that one? Okay? And the real answer would be 1 over x minus 3. X cannot equal 2 or 3. That is the real answer, because 2 was bad here. I must always put it as a non-permissible. It is never allowed to play the whole time.
So if it's on the bottom.
It's bad. If it makes the bottom equal 0, not good. If it makes the top equal 0, who cares? And if you're deliberate writing that in on your study sheet, actually write. If it makes the top equal 0, it doesn't matter. Yes, what do you think they're doing when they get you at the diploma? They want to know, do you know these subtle little differences? Okay, that's why a math diploma has the highest standard of deviation than any other diploma by far. What does that mean? Most spread out. There's people that actually try their hardest and get 5% on the diploma. Now, they missed every class, but they are their diploma day. That's what's hard about big high schools. I've taught at big high schools, and this kid walks in, you're like, who are you? Right? They're like, well, I haven't come all year, but I want to rate this baby. And you're like, well, why? I don't know. You know, maybe I'll get 100 on it, and then I'm done the course, right? And you're just like, okay. And, you know, they do try. I mean, they don't just come in and guess everything, because then they'd get 25%. But they actually try their best, and they get 5%, because there's so many little things, okay? And there's, if you use common sense, often, you know, like if you wanted to, how do you multiply two graphs together? How do you add two graphs together, right? So one of them would have the one graph added onto the other one. Well, that's kind of intuitive to say, yeah, I'll pick that one, like they added them. I get it, yeah, right? But we know now that obviously you have to find out the points and add the y's. Now, if we look at example 2, I'm going to do it because it has a different type of factoring, so I'm going to review that. So 2x squared minus 13x minus 7. Okay? So again, just kind of gauging it from last class, they were just like, oh yeah, those ones, okay? This one is called the type 2 because there is a number in front of the x squared that isn't 1. So we do these by going what plus what equals negative 13 and what times what equals negative 14, right? So remember, we multiply these two together to get that one. Okay, so I'm going to go pretty slow on this one because we want to make sure we remember how to do these. Now, the two numbers would be negative 14 and 1, right? Now, we just don't go x minus 14, x plus 1. Because of the 2 in front, we have to do these totally different, and we would call this 2x squared minus 14x plus 1x minus 7. So we take those two numbers, and they go into the middle because negative 13 is negative 14 plus 1. And then we put our brackets in, the first two and the last two. Order doesn't matter. If you were to put plus 1x minus 14x, you will still get the same answer in the end. The front 2, I'm going to take out a 2x, leaving me with x minus 7. Okay. Now the other one you want to be very kind of purposeful of. I want it to look like that one. So if I do take out a 1, I am left with x minus 7. And it's always a good day when those two sets of brackets are the same. So the answer is x minus 7, because I could take out an x minus 7 out of both of them. And what's left? 2x plus 1. Okay? So it was just a little stroll down algebra lane. Especially at night. So, we really haven't done the question yet. We just got the top, right? So, if we go up here, I got x minus 7, 2x plus 1, all over 2x plus 1. Cancels, cancels. Your answer is x cannot equal, or sorry, x minus 7. X cannot equal negative 1/2. All good? Okay. So we're going to do this one here. What does 3 fg of 2 equal? Well, all this means it's take 3 and multiply 2 fg of 2. Now, fg of 2, that is 2 times, now I'm putting a 2 in there, right? 2 times 2 over 2 minus 1 times 2 over 2 minus 3. So I have just put in 2's for x's. So this is 3. 2 times 2 is 4 over 1 times 2 over negative 1. So that would be 3 over 3 times 8 over negative 1. Okay, now even from here, some people are like, what do you do? Well, this is the same thing as 3 over 1. So multiply your numerators together, gives you 24 over negative 1, which equals negative 24. I'm just going to write that here, so it's not so tight. Okay, so C and D, we're going to do everybody's favorites, adding 2 rational expressions and dividing 2 rational expressions. Now, addition and subtraction of rational expressions, they're not fun. Okay? We got to keep remembering that you cannot add or subtract without a common denominator. Okay? So let's do like a grade 7, grade 8 question with numbers. So then when I go to do the one with rational expressions, you can see I'm not changing the rules. So if I have to take 1/2 and I have to add 1/3 to it, okay, that isn't 2/5. You can't add or subtract until the denominators are the same. Now, what would be a common denominator? 6, okay? But I want to be even more, I guess, transferable to what we're going to learn. And I'm going to say that a good common denominator would be 2 times 3. Yes, it's 6, I get that. But what I can do is I'm going to do this. I'm going to put this over my common denominator. Now again, if I was teaching addition of fractions to grade 8s, I wouldn't do this. Right? I would go, let's go on 6, and then we'd go blank over 6 plus blank over 6. And then what I want to do, I'd go say, what do we have to do to 2 to get 6? We'd go multiply by 3. Okay, we'll do the same to the top. But this is, do you see what I had to multiply? The bottom, I had to multiply the bottom by 3 to get 2 times 3. So I'm going to do the same thing to the top. Right? And then what do I have to do to 3 to get 2 times 3? Well, I have to multiply by 2. Okay? So if you have to multiply by 2 here, we're going to multiply by 2 here. So that's going to be... So then I would get 3 over 6 plus 2 over 6. See, I haven't changed the question. Now, I know you can argue, yeah, because it was 1 on the top. Now you have a 3. But you're not getting any more if I say, instead of 1/2, I'll give you 3/6. You're not getting any more because I've changed both the numerator. They're the same. They're both 1/2. But what this does, it gives me the ability now to add them together. And what happens to the denominators? They stay the same. That doesn't turn into 12. And 3 plus 2 is 5. Now I want you to take about 10 seconds and look at this, because I want to use the identical rules to do rational expressions. And if you say, well, how come you're not adding the denominators together? I'm going to go, did we add the denominators together in grade 8? No. We're going to stick with that rule. Okay? So what you used to know, you got to keep in mind. And if you start to lose your bearings, then think about the easy question of 1/2 plus 1/3. And what did you have to do there? Okay? So I'm going to do the same question. I'm doing 2x over x minus 1 plus x over x minus 3. So, the first thing I need to do is come up with my common denominator, which would be x minus 1, x minus 3. X minus 1, x minus 3. Just like we did in grade 8. Now, you can see the top, or the bottom, sorry. To get x minus 1 to x minus 1, x minus 3, I had to multiply by x minus 3, right? So, I'm going to do the same thing here. And this one here, to get x minus 3 to look like x minus 1, x minus 3, I had to multiply by x minus 1. So I'm going to do the same thing to the top. And now they can be added. And do you see how when I had the common denominator, it was the new denominator? So this will be, well actually let's just do this one step first. Let's multiply this in. This would be 2x squared minus 6x over x minus 1, x minus 3. And this is going to be plus x squared minus x all over x minus 1, x plus 3. Okay, now the one thing I can guarantee you is this is what my bottom is going to look like after I add them together. Just like look at the 6's. 6, 6, 6, this is, right? Same thing. So then I got 2x squared plus x squared would be 3x squared. And then minus 6x minus 1x would be minus 7x. Now really, I guess if you technically wanted to factor it a bit better, you could take out an x, 3x minus 7 all over x minus 1, x plus 3. Now I do recommend doing that step because sometimes when you do that, then we have a cancellation of top-bottom. I want to see, would you go one step farther? And the diploma would never have both answers. They would not have the one they didn't factor quite enough, and then D is the one they totally factored. Okay, they don't do that. Even if they say in the question, factor this as far as possible, and they got it in, you know, we've taken, you know, when field tests come, we will always, like if I ever see two of the same answers, but I know one you simplified more, that's the feedback I would give, is that I just think that's just mean. If you give both of them, like look how many steps we had to get through, and you had step 5 on there and step 6 on there, that's pretty weak. If you want to actually test students' knowledge, that's not a way to do it. The question isn't done because I would have to state that x cannot equal what? Okay. How did I change this to plus 3 all of a sudden? There's like 800 of you in here and no one caught it. All right. Then you quit because I thought I factored the x out, and I thought that's what you're talking about. Don't be scared. This is getting taped, right? People at home do not want the wrong answers. They'd be sitting home right now yelling. What would be the way we would do division? Now, division actually, interestingly, is way easier than above, but more people would get it wrong because of one little thing. So if I had 2x over x minus 1, it says take this and divide it by x over x minus 3. Okay? Then we have to do multiplying by the reciprocal, right? So then I would get 2x over x minus 1 times, I'm gonna use a dot, okay? Times, so my x's don't start to get all confused. X minus 3 over x. Okay, what's really nice here is now that I've done this, my x's will cancel. And then I get 2x minus 3 all over x minus 1. Okay. X cannot equal what? Zero? Because it's bad here, right? Okay. Now, 3 3 is okay, right? Because if I put 3 minus 3 in there, that's 0, and 2 times 0 is 0. I'm allowed a 0 on the top. But it was bad there. So 3 is bad because it was once bad. Now, the reason why I had to go through that is after I do this question, that's why students start putting non-permissibles up top, because they're like, Mr. Trimmy, you did it in this question. Look, it's right here. You said that 0 is not allowed there. And I would go, no, 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 no. That's not why I have that. This is why I have that. Now, in your notes, that's good stuff to put, because I know, like, you know, how many of you, there's like 70 of you in grade 12, there's going to be one of you that's going to think you can't put 0 up top. You can, okay? So that 3 is not there because of the final answer. It's there because in the original question, 3 was not allowed. I know the argument, but you flipped it, so now it's all good, okay? No, if you were suspended for the tournament, you missed the whole tournament. Okay, you don't get to go. I thought it was just Friday. Like Saturday too? Yeah, the whole tournament. That's kind of what the whole tournament means, right? I didn't mean you could come the second day. So that's why the biggest distractor would be, it would just say x equals 0, cannot equal 0 or 1. Most students would pick that. They would forget about the 3. Okay, so let's do 1 to 4 and 8 to 11. No. Just a guy I know. Actually, I think it was Mr. Pierce was saying he had a student that was suspended for 1 game. But a tournament was coming up that weekend, and he had to miss the tournament too. The kid's like, what? That was for like my league. And then in the rules it says if you're suspended for a game and a tournament falls between that time and the game, you miss the tournament as well. That happened to him a couple weeks ago. So play fair, kids. That's the moral of the story. Yeah. Just going to scroll through the questions here. So okay, guys, you have lots of time to finish. And not those people around you that do not have time tonight. Give them the gentleman.